In this example, we want to determine whether each of the systems of three linear equations in A and B, C and D are in triangular form or not. And just to recall what triangular form of a linear system means, the definition is down below. So there are a couple of conditions we need to check. That in each equation, the variables are listed with the x terms first, then the y term, then the z term on the left side, and the constant term on the right side. The last equation should not have any x or y terms in it. The second equation should not have any x terms in it, and we need to make sure that the leading variable in each equation has a coefficient of 1. So checking these conditions, starting with A, first we see that the first equation has x, no y, and then z, no x, y, and then z, and the last equation has a z. So the first condition is satisfied. They are listed in increasing order in each equation. The third equation down here has no x and y's in it, so that checks out. The second equation has no x's in it, so that checks out. And the final condition, each of the leading terms has a coefficient of 1. So there's a 1 in front of the x, a 1 in front of the y, and a 1 in front of the z. So A checks out as yes, that is in triangular form. Moving over to B, we can see that in the last equation on the bottom, we have a problem, and that is the y term over here appears in the bottom equation. And recall, down here, that shouldn't happen. So this one is not in triangular form, but we could very easily put it into triangular form by doing one more operation that wouldn't change the solutions. Namely, we could interchange equation 2 and 3. And in doing that, we would get equation 1 would be x plus 13y is equal to 6. Equation 2 now would be y minus 3z is equal to 0, and the last equation would be z is equal to 2. And now this would be in triangular form, and from that we could determine the solutions pretty quickly. For part C, we've got a problem with the second equation in that the coefficient here is 4. And we can see that for a system to be in triangular form, the coefficient in front of the leading variable should be 1. So this is not in triangular form in part C, but we could put it into triangular form by replacing equation 2 with 1/4 E2. So if I were to multiply every term in equation 2 by 1/4, the top equation would still be x minus y plus 2z is equal to 18. And now this equation would be y plus 1/4 z is equal to minus 1/4. And then the last equation would be z is equal to 20. And this, for example, would be in triangular form, because now the leading coefficient in front of the leading variable is 1. And lastly, looking over in part D, for this equation, this one is in triangular form. The terms are listed in increasing order in each equation. I have x, no y, and z. Here I only have y, and here we only have z. The last equation doesn't have x or y in it. The second equation doesn't have any x terms in it, and the leading coefficient, the coefficient with the leading variable, is 1 in each of these equations. So equations A and D were in triangular form, B and C were not, but we could put them into triangular form doing one more operation to them.